Hey everyone! Today, we are diving into a process that honestly feels like it's pulled straight out of science fiction, but it's happening right now and it's completely reshaping our world. We're talking about a kind of high-tech alchemy called electroless plating, and believe me, it's changing everything from the device you're watching this on to the future of clean energy. Let's get into it. Okay, just think about this for a second. Imagine you've got a super complex 3D printed part, with all these crazy angles and tiny little crevices. How in the world do you cover that thing in a perfectly even, super durable metal shell? I mean, you can't just spray paint it, right? That would be a blotchy, weak mess. The answer is way, way cooler. And that's where electroless plating comes in. The best way to think about it is like a smart chemical bath. You just dip an object in, and a perfectly controlled chemical reaction makes a layer of metal literally grow on its surface, atom by atom. It gets into every single microscopic groove, creating this seamless metal skin. And the craziest part? It does it all without a single jolt of electricity. So here's what we're going to cover. We'll start with the basics of what this process actually is, and why getting it just right has been such a huge headache for so long. Then we'll get into the really cool stuff, the high-tech solutions scientists are using to master it. We're also going to talk about how it's becoming surprisingly eco-friendly. And finally, we'll look at the incredible future this tech is unlocking. All right, so let's break down what this is all about. This isn't just some obscure industrial process. It's a foundational technology that makes so much of our modern world actually work. So what's the big deal? Well, its power is in its versatility. Because it doesn't need electricity, you can coat pretty much anything, plastic, ceramics, you name it, with a perfectly uniform metal layer. This is absolutely critical for the tiny circuits inside our phones and computers and for turning lightweight 3D printed parts into strong, functional components. You're creating surfaces that can protect against rust, conduct electricity, or a dozen other things. But of course, there's a catch. While the idea sounds simple enough, actually making it work perfectly in the real world, incredibly difficult. Getting a flawless, pore-free coating has been a massive scientific challenge for decades. You see, down at the microscopic level, it's a total chaotic dance. As the metal is forming, tiny little hydrogen bubbles can pop up and create microscopic potholes in the coating. The chemical bath itself is notoriously unstable. The tiniest impurity can throw the whole thing off. And on top of all that, the process traditionally creates some pretty nasty chemical waste. These were the roadblocks for engineers for a very long time. But now, things are changing big time. Scientists have developed a whole new high-tech toolbox to tame this complex process, turning it from a tricky, almost black magic art into a precise science. First up in the toolbox is artificial intelligence. Yeah, you heard that right. Instead of just crossing their fingers and hoping the chemical bath stays balanced, researchers are now using AI to monitor and actually predict the chemical concentrations in real time. It's like giving the whole process a brain that can see problems coming before they even start. And the results? They're really impressive. Research shows that by using a specific type of AI called Bayesian machine learning, scientists can predict the bath's chemistry with up to 32% more accuracy. That is a huge leap, giving them a level of control over the process that was just unthinkable before. Okay, next up, sound. To deal with those annoying little hydrogen bubbles we talked about, scientists are now blasting the process with high-frequency ultrasonic waves. What they're basically doing is shaking the part at a microscopic level, literally knocking any bubbles or impurities loose before they can get trapped and mess up the coating. And the impact is just incredible. One study found that using these sound waves can slash the number of tiny holes, the porosity, in the coating down to just 0.03%. That is about as close to a perfectly solid, flawless metal skin as you can possibly get. It's a game changer for high-tech applications. The third major breakthrough is all about teamwork, combining electroless plating with 3D printing. This hybrid approach lets you create things that have the complex, lightweight shapes of plastic, but the strength and functionality of metal. It is truly the best of both worlds. And this comparison really says it all. On the left, you've got your standard 3D printed part. It's light, but it's also got a rough surface, and it's not very strong. But look at the right. After plating, it's smooth, it's conductive, and it's incredibly tough. Research has shown this can literally double the surface hardness and make it way more resistant to scratches. It's a total transformation. Okay, so the tech is amazing, but there's a big elephant in the room, right? What about the environmental impact? Well, this is where the story takes another really fascinating turn, moving away from a waste problem and towards a sustainable solution. And it's a totally fair question.
For a long time, this has been the Achilles heel of the whole process. But now, new research is flipping the script and turning this waste problem into a resource opportunity.
Let's just look at the numbers for a second. One new system was able to recover nearly 95% of the valuable nickel from the wastewater. That is a massive amount of metal that's now being captured and reused instead of just being thrown away.
But it doesn't even stop there. Another, even newer method uses these tiny things called catalytic nanoparticles to remove over 99.99% of the nickel from the used chemical baths. I mean, at that point, you're talking about essentially perfect purification.
And here's the best part. This isn't just about cleaning up a mess. That recovered nickel is being turned into brand new, high-value products, like key components for next-generation sodium-ion batteries. This is the circular economy in action, taking industrial waste and turning it into a high-tech resource.
So when you put all these pieces together, the smarter control from AI, the physical perfection from sound waves, the versatile new materials from 3D printing, and the green chemistry, a really clear picture of the future starts to form. This isn't just a small improvement, it's a full-on manufacturing revolution.
So the takeaway is this. We now have the tools to make this process intelligent, physically flawless, unbelievably versatile, and environmentally sustainable. And each of these innovations just makes the others even more powerful, creating this incredible toolkit for building the world of tomorrow.
And this is going to unlock technologies that we've really only dreamed of so far. We're talking flexible electronics that you can literally weave into your clothes, hyper-efficient fuel cells to power our future, and smarter, more biocompatible medical implants that work seamlessly with the human body.
This technology is giving us the power to completely rewrite the rules for physical objects. We can make almost any surface lighter, stronger, smarter, and more durable, all while getting rid of the waste. So that really just leaves us with one final, very exciting question. What are we going to build next? Thanks for tuning in.